Complex Numbers, page 8, just a bit of an introduction to modulus argument form of a complex number. There's two ways of expressing a complex number. We've looked at one of them up to now. We've been looking at this real and imaginary format, x plus iy, or we sometimes write it as a plus bi. That real and imaginary two components. Now, what we're going to look at now is this, which is something that you need to memorize. This is called the modulus argument form. Now, the modulus is this number r at the beginning. R is the modulus, like it says here, and theta there is the argument. Now, I just want to do a quick demo to show that these two actually give you the same thing, and I've left example 11 here up at the top. So what I've done is I've done inverse tan of 3/4, and I've got the full value for this rather than the rounded value, and I've saved it in my calculator. So if you just do that yourself now, inverse tan 3/4, and then store it as a or any letter you want. Now, we know that this complex number was 4 plus 3i. That's this format, the one that's underlined in green. What I want to do is just write it in this format as well to show you how you would do that. So we've worked out the modulus and the argument. So the same complex number in mod arg form, modulus argument, mod arg, would be 5, that's r, the modulus, and then you'd write cos 0.644 plus I sine 0.644, and that's how you'd leave it. That's the answer. That is mod arg form. But what I want us to do is just have a little check by multiplying out that we can see that these two things are the same. So on your calculator, first of all, multiply these two parts together. That's going to give you the real component. So do 5 times cos of a. And if you've stored the full value, as if by magic, you should get that they multiply together to give 4, which is what we were expecting. And then if you do the same thing with the imaginary components, just leave the I, don't put the I in your calculator. That's just how many i's. So you're going to type into your calculator 5 times sine of a, or whatever you've got it stored as. And when you do that, you should find that it works out perfectly to be 3. Which is what we had to start with. So these two formats are exactly the same, and sometimes you're asked to express things in mod arg form. A couple of little facts that you need to know, and you can check this with two complex numbers yourself if you wanted to. If you multiply two complex numbers together and then find the modulus, it's the same as finding the two moduli individually and then timesing them together. So in other words, it doesn't matter if you times them then find the modulus, or do the modulus and then times them together, you get the same answer. So that's a result you need to be aware of. It doesn't often come up on the exam, but it's something that is listed, so we need to be aware of it. Similar result works there for division. The proofs of these are quite difficult, and they use some C3 trigonometry, so we won't go into the proof at this stage, but you could try it with a numerical example if you wanted just to have a bit of a justification of it. And then similarly here at the bottom, just out of interest, it's not actually on the syllabus, this one. If you multiply two complex numbers together and find the argument, it's actually the same as doing the argument of each individual one and adding them together. And I mention that because it's a little bit similar to that law of logs, isn't it? The second law of logs. And you could probably make a prediction about what happens when you divide two complex numbers. Same as the third law of logs. I'll leave that one with you to have a think about. But anyway, these two are ones that you definitely need to be aware of.